Okay, I think we are live. How's it going, guys? This is going to be I'm going to try and keep this as a pretty short-ish live stream because I only get 30 gigabytes worth of tethering a month on my 4G mobile phone plan, and my broadband internet is not quick enough to actually stream from, so I'm having to tether from my 4G phone, which is quick enough to tether from, but I only get 30 gigabytes, so there's only so much streaming I can do every month, which is very annoying. But anyway, this is a Banda Viking 7000, something we chatted about in the last video. However, this one has a different fault. This one has a different issue, and it's something that I think it's worth showing you guys because I think I've just found it. This is an issue that I've been looking for now for a few months. I've got two boards that share this same issue, and I'm going to explain what the issue is and how to resolve it. So this is a very bare looking Viking 7000 board. We have removed all 4 main rail capacitors, and that makes the amplifier much safer and easier to work on because you're not storing 125 volts on the output section. Dawn says, I'm sorry to hear about your plan, but you seriously need to keep making these. This kind of video is going to catch on. Thank you very much. I appreciate the kind words there. I shall do my best to try and overcome the issue with my 30 gigabyte limit. Is the stream offline? I don't know, is the stream offline? Looks okay to me, my friend. Yeah. Anyway, so I've removed all 4 main rail capacitors, makes it safer to work on. I've removed all the output MOSFETs, and I have removed all 4 driver chips here. Now, the fault that I was searching for a long time has to do with the outputs here. So this amplifier is a full bridge amplifier, which means that both positive and negative speaker terminals are active. One pushes and one pulls. It's like having 2 amplifiers in bridge mode. Think of this amplifier cut in half along here, and you've got 2 separate sides that are in bridge that do this and push and pull the speaker from plus and minus out of phase with each other. Your zip pants is open. No, it's not, my friend. It is just a pretty crappy design. It's actually buttoned up very nicely. Yes, it's amazing. These are my workshop jeans, so they're not the best of jeans for sure. They're very old. Anyway, so yeah, so these work in a push-pull configuration like this. They also have, because this amplifier only has a single rail voltage, so this amplifier, the power supply, generates about 125 volts worth of positive rail. So in order for the amplifier to swing the audio signal up and down, it needs some reference of high and low. It needs to know what to swing up to and what to swing down to. So to do that, rather than having like a positive 80 volts and a minus 80 volts that the audio swings between, it cuts the rail voltage roughly in half and puts half rail voltage on each of these speaker terminals. So when you power the amplifier up, you actually see about 70 volts DC sitting on each of these speaker terminals. And obviously they have to be exactly the same. If you hook up a subwoofer to these speaker terminals, if one of these is 73 volts and one of these is 70 volts, then the speaker's going to see 3 volts worth of DC, and it's going to go poof and just pop upwards. And that is called DC offset. And you don't want DC offset on your outputs of a full bridge amplifier because that shows that there's a fault. So when you power this amplifier up, the idea is that you see the exact same voltage on both of these positive and negative outputs, so that the speaker doesn't go poof and stay anywhere or suck inwards or anything like that, and the audio can then swing between the top of the rail voltage, 125 volts, and 0 volts being the bottom. That is the plan, and that's how this amplifier works. The problem that I have been having with these amplifiers, with 2 of these boards now, so I've got 2 of these amplifier boards that have the same issue, is that when I make a repair, like 2 of the MOSFETs will be blown. So I change the 2 MOSFETs, I change the driver, and I change the pre-driver chip all the way over here. Even when I do that, when I test it on my small power supply here, I turn the amp on, seems to work fine, switching waves look great, it outputs audio. But then when I turn the amp off and I remove my remote cable from the amplifier, suddenly the rail caps dump all of their charge through the same 2 MOSFETs and they instantly blow. And I was like, the first time it happened, I was like, what the hell? I was checking for solder bridges, and I cleaned the board up a bit, and I tried again. I took those two 90 and 20Ds off, I fitted two new ones, and I tried again. And I was like, turned it on, checked the board over, yeah, waves look good, turned it off, poof! All of a sudden, they blow again. And I was sitting here going, what the actual fuck is going on? I've changed the driver, I've changed the fets, I've changed the pre-driver. What else can be causing this? And this has been an issue for a couple of months now. And I haven't been able to find it. So today I need to get this done, and so I found a second Banda board with the same issue. So I was like, right, this is obviously a common issue that happens when these amps blow, is that something dies which causes these fets to blow when you remove the remote. So I spent a couple of hours looking for it today, and I think I found it, so I wanted to show you where the issue is in case you ever come across this problem when you're repairing a Banda Viking amplifier or similar. So what I'm going to do is I'm going to show you a few things on the scope here. I'm just going to tell you what I've removed. So if we zoom in here with my zoom in camera, I've already said that I've removed all the MOSFETs. I've removed the driver ICs, which are these pads here. This is where the driver IC goes, and this is a 2010S chip. So that's been removed. I'm just going to sort this camera out. It looks a little bit blurry to me. That's a little bit better. And I've also removed, there's another thing that I've removed, which is just here. So there's a tiny resistor that goes here, and this resistor is a 104. So it's a 10,000 ohm resistor. So you've got the driver that's removed, and you've got a 10,000 ohm resistor. Now the reason that I've removed the 10,000 ohm resistor is because this resistor is responsible for setting the voltage on the speaker outputs. So it takes the main rail voltage, which is on this pad here, underneath this big ass resistor. So underneath this 0.03 ohm resistor, you've got the main rail voltage, and then this gets sent to this pad here, which is the pad for the 10,000 ohm resistor, and on the other side of the resistor is where the rail voltage is, or the half voltage, if you like, is set for the speaker terminals. So because I was getting some DC offset, I noticed that one of these speaker terminals was 74 volts and the other one was 70 volts. So I had like about 4 volts of DC offset. So I was thinking, right, I was trying to find where on this board is this half rail voltage generated. I was looking around, I was trying to work out where does this 70 volts come from, because obviously that part of the circuit is an issue here. So I was looking around the board, and I found eventually that the part of the board that generates this half rail for the speaker outputs to oscillate between is partly responsible by this small 10,000 ohm resistor here. So I removed that on both the good side and the bad side. So if you see here, I've got two sides. This side was working fine and had the correct voltage on this side, but this side was faulty and only had 70 volts, so about 4 volts lower than it should be. So I removed all of those resistors from each of those banks because I want to see what the good side looks like when I remove the parts and what the bad side looks like, and so I can compare them and try and find where the fault is, which has been very helpful. So now I'm just going to power the board up for you and show you a few voltages around the board so you can see how I found where the issue is. How's everyone doing today? What have we got going on in the live chat, just very quickly? Black Hawk 5069 says, how do we send you an app for repair? You can only send an app for repair if your vehicle is okay, because it costs too much to ship and it's needless to repair. You actually go on buying it look to put it to the board. Audio Gold says, hey man, I love your work. Please help me with some info. I have a ground 0 500. Do you ever code the output fets with 20? Okay, can you guys hear me yet? Is that any better? Mic check 2. Mic check 2, 2, 2. Any better? Fixed? Okay. That's weird. Sorry for that, guys. Little wake-up call with the audio there. I bet that sounded horrific. Sorry about that. Not sure why that was. Let me know if that happens again. I'm going to keep an eye on my audio level bar. Yeah, weird. Okay, anyway. So I was just having a quick look through some of the comments. I don't know where you guys lost my audio, but yeah. Okay, what we're going to do is I'm going to show you some of these waves on this amplifier, so that you can see how I found the fault, how I located it, and what's going on. So, with this amplifier, I have removed the main rail capacitors, because by moving the rail caps, it turns on instantly because we're not charging any caps, and also it makes it a lot safer to work on, because I was going in some pretty heavy depths with this amplifier, so I needed it to be safe to work on, and I needed it to turn on very quickly. So, let's turn this amp on. And let's show you some stuff on the scope. So with our multimeter probe, we can have a look at what the main rail voltage is. So if we probe here, we can see we've got on the scope screen there, where's my scope camera? There it is. We've got 123 volts of main rail voltage. So this amplifier has one main rail. It's just generating 123 volts worth of DC voltage, and this is with 9.8 volts worth of input. Is the audio still good? Yes, it is. The audio is still good. Good stuff. So, because what I said earlier is this amplifier generates a lower half rail voltage for the speaker outputs. I've removed the driver and I've removed the resistor, which is responsible for creating that half rail voltage. So, what do we have on the speaker outputs now? So, because I had DC offset on my speaker terminal. So one speaker terminal was 74 volts and one was 70 volts. So I've removed all the resistors that were responsible for generating that lower 70 volts, that's lower than 123 volts. So what I'm going to do is probe the speaker outputs here and see how they act now that I've removed that resistor. So let's turn the amplifier off, let's probe the good side, and let's see how it's supposed to react. Turn the amplifier on. Looks like it's not meant to do anything. So this is meant to stay completely at 0 volts without the resistor in place, which would make perfect sense. Now let's probe the bad one. So this is the bad side over here. I'm going to probe the bad one, and you can see that we have some weird kind of fluctuating -1 volts, -2 volts all over the place. This is with the amplifier turned off. So let's turn the amplifier on. Ah, wow, it's all over the place. Look at that. So we jumped up to kind of 6 volts, and now we're falling down 4 volts. If we go back to the good side is still sitting at 0. Yeah, so the good side, this amplifier is not meant to have any voltage jumping around on the speaker terminal output when this resistor is removed. But on the bad side, it's all over the place. When I remove the remote, you can see that the voltage fluctuates down -3 volts, and that is what was causing these MOSFETs to blow when you remove the remote. Let's show you that again. Turn the amplifier on. We have positive noise wobbling around. That's not good. But the amplifier will still operate with this. The amplifier will still work even though we have this slight DC offset, especially if there's not a load which is connected to the amplifier. When we remove the remote, when we turn the amplifier off, look what happens. The voltage swings to negative, and because the voltage swings to negative, this will cause the MOSFETs to turn on because the gate and the source is then offset and different, and it's enough. It's just enough of a difference to turn the MOSFETs on and completely dump the rail voltage from the rail capacitors through the MOSFETs and kill them. So this is our problem. We have some issue on this speaker terminal, and we need to find out why. So I was looking at the drive circuit area here. Let's zoom in. So this is the drive circuit area, and I think this is where the fault's going to be. So what I was doing is I was having a look at these capacitors here. So by the driver, we've got 2 capacitors here. We've got a big one here and a big one here, and 2 smaller ones here. So what I was doing is I was probing around these capacitors, like this one here for example. I was turning the amplifier on and seeing what voltage we had, over by these capacitors. So you can see with the amplifier off, by this capacitor here, we should have on the scope screen there, if you can see, we've got 11.89, 11.6 volts. So this is the trend. This is showing me that there is a capacitor that is charged and it's holding 11 volts. If we turn the amplifier on, it bumps it back up to 11.85. So we've got 11.86 volts on this capacitor, and when I remove the remote, it stays there and slowly discharges. You probably can't see that on the screen there. If I zoom in, we've got 11.4, 11.6, 11. We're slowly falling back down. So this capacitor is now discharging. If I apply the remote again, then the capacitor charges back up fully to 11.85 volts. Now, if I do the same on the other side, so if I go over to the bad side that we have the issue on, that we have the DC offset and the side that was blowing the fets, if I probe the same part, the same capacitor and the same point, okay, so that was over here, I think we need to probe this bit here. Okay, so you can see when the amplifier is turned on, we get the same voltage. So when the amplifier is on, it's the same as the other side. But when I remove the remote, as soon as I remove the remote, it doesn't hold its charge. It falls straight away. So it's not holding its charge like the good side is, which means that we have a bad capacitor over here. So it's not holding its charge. If I go over and probe the good side again, the good side still has 11.79 volts on it, but the bad side has 2.6 volts on it now. So there is our issue. And this took me flipping forever to find. Absolutely forever to find. And this is interesting because if we probe the other, so I'm going to go back to this capacitor over here. I'm going to go back to this capacitor over here. So we were probing this side of the capacitor here, which has got the 11.83 volts. If we probe the other side, if I go to the other side of this tiny capacitor, you can see that on the scope we should have nothing, absolutely zero. When I turn the amplifier on, we've got 0. When I remove the remote, we've got 0. If I go over to the bad side capacitor now, on the other side of the board, if I probe the other side of this capacitor, which I believe to be bad, we've got DC voltage. Look at that, we've got 6 volts. So that means this capacitor is leaking. So we've got a leaking capacitor here, and when I turn it off, it swings down into the negative, and that, my friends, is what is killing our MOSFETs. So what we need to do is we need to remove, and it could also be the ones over here. So we've got a bad side. So what I'm going to do, I'm going to refresh this side completely. I'm going to remove all 4 of these capacitors. I'm going to remove all 4 of the very, very small surface mount capacitors, which are these ones here, right next to these on the bad side. And hopefully that should resolve our issue. I'm not going to do that on live stream though, because that'll take a while, and I want to save my gigabytes on my phone tethering so I can do more live streams for you. Let's see what we've got in the chat. I'm glad the audio is still good. There's a lot of German going on in the chat, or Swedish or something. I can't read that. Yep, definitely a lot of some other language that I can't read going on in the chat. Yeah, no worries. So just to recap, for anyone that has just joined us on this live stream, how many people have we got watching? 40 people watching, not too bad for this time of day. So just to recap then, for anyone that just joined, we have a Banda Viking 7000 on the bench. This amplifier was blowing 2 MOSFETs when we removed the remote. What the fuck, man? This is never, I've never seen this issue before. So when we removed the remote, 2 MOSFETs were dying instantly the second we removed the remote. And this amplifier also had DC offset on the output terminals. So these terminals should have about 74 volts worth of DC on them, because that is about half rail voltage. That's how this amplifier works. It's a full bridge amplifier, so we need half rail voltage on these for it to work. But they have to be exactly identical. The voltage has to be exactly the same on them for this to actually work. And I had about 4 volts of DC offset. One side, the bad side, was down at 70 volts, and the good side was up at 74 volts. So I was like, not only is it blowing MOSFETs when you remove the remote, I've also got DC offset. So I started removing parts of the amplifier until I found the issue. I removed all of the MOSFETs. I powered it up, we still had DC offset. I removed all the drivers, I powered it up, we still had DC offset. I found and located the small resistors which are responsible for setting the voltage on the outputs here, the half rail voltage. I removed all of those, and we no longer had any DC offset, but the bad side, the voltage was fluctuating all around over the place. With these small resistors removed that are responsible for generating the voltage on the outputs here, with those resistors removed, the good side showed me that we should have absolutely nothing on this terminal with that resistor removed. We should have nothing, 0 volts DC. On the bad side, however, it was jumping around between about 6 and -4 volts, so I knew that there was an issue somewhere. So I just probed things around the drive circuit until I found a few capacitors here that appeared to be leaking, and that was causing the rail voltage on this terminal to fluctuate around all over the place, and that is our issue. Hello, my friend. Has a ground zero 4K, it turns on, but as soon as you turn on music, it goes into protect. What's the problem? So it powers up, but as soon as you turn music on, it goes into protect. So have you tried it without a load attached to the amplifier? Does it play clean music, just without a speaker attached? If you turn an oscilloscope to the outputs, does it play a cleaner sine wave or not? Check that first. It's Dutch. It's Dutch. Okay, awesome. I'm glad that we've got people from all around the world in the chat. That's wicked. So, if I look into data sheets, I can't find 65N25, but there's 62N25. QG on your replacement fets are way higher than the. This is in response to the other ones. Yeah, the 60. It's not 65N25. It's 69N25 are the ones that I would recommend. I've got a whole bunch of them here somewhere. Here we go. 69N25s. These are really good in amplifiers from about 2K to about 4K. They're very, very easy to drive. They have very high current handling, good pulse drain current handling. Yeah, they work really well. They're very good in the ground zero 4Ks. I put some in a Hyphonics 3.2K as well, which worked lovely. Love the amplifiers, keep it coming. Thank you very much. Come to Italy. Yeah, man, I'll come to Italy. I've been to Italy a few times. Greetings from Germany. How's it going, buddy? How's it going? So yeah, I've pretty much exhausted what I wanted to explain in this live stream. So I'm going to put this up now on YouTube for people to see. Hopefully, if they have the similar issue with these Banda amplifiers, I would recommend, highly recommend, when you're repairing this Banda amplifier, when you're repairing it, because of how these things blow, take everything off the board, all the output MOSFETs. There's only 8 of them. It's not too difficult. Take all 4 drivers off the board. It's not too difficult. There's only 4 of them with your hot air station. And once you've done that, then check for DC offset on the outputs here. Make sure that they are exactly the same voltage, because the amplifier will be, you can repair the amplifier fine and it will seem to work even if there's an issue, but it won't last very long. So I would highly recommend that you look into this area here and check all the capacitors around this area. Make sure that they haven't got anything funky going on with them. Make sure you haven't got any DC offset voltage on the output terminals here. So thank you very much for tuning in, guys. I'll probably do a further live stream a little bit later on this evening, and we're probably going to start looking at a big amplifier, maybe a DC 9K or a Vibe Reaper, which is basically a 10K board. So yeah, thank you very much for watching, guys, and I shall see you a little bit later on.